All right, friends. So what I wanted to do is give you a little bit of a discussion about the exam. Exam's not due for a little while, but I wanted to give you something to get you started. Okay, so we'll go ahead and share my screen and let's take a look at it. So this is the schedule as I see it right now. And we've got the exam opened here, and here's the exam. Okay, and then we want to develop a collection of 4 different rules for generating terms of a sequence. Generate a program that for randomly selecting the rule and a starting point, and give the user the first 4 terms of the sequence. Ask them to guess the 5th. Tell them if they were correct or not. Okay, that's a lot to remember. So this one, I'm primarily going to focus just on the programming side of it. So um, well, let's go ahead. I think I'd like to just program this in Eclipse. So I'll just do a search right quick for Eclipse. And I'm actually not sure what workspace this is going to open up into, but whenever I'm going to do a program, let's see, story time. Let me move this little thing right quick. Yeah, no, Eclipse workspace. This is the one that I think is just kind of a standard workspace. Hopefully it's not too fancy or anything like that. Probably going to be needing to reinstall Eclipse here pretty soon because I think I'm starting to run on an older version of Eclipse. But this is something that hopefully coming out of a computer science 1 class, you're going to be able to work through things like this. All right, so see if I've got a discrete structures. You know what? I think I need to just have a new package for discrete structures. So I'll just create one right quick. I'll call new Java project, and I'll just call this. All right, we'll use the default Java runtime environment, and let's go ahead and finish that. I'm not going to use the module, so I'm not going to create that. I'm going to come down here. I'm going to go to team, and I'm going to hit share project. And I want to share this with the Eclipse repository. I think that just works better. So I'll go ahead and click finish. Okay, so I'm going to do a new package now, and I'm going to call this exam 1. Oops. Okay, finish that up. And now I'll come in here and I'll do a new class, and I'm just going to call this main. I know it's not real fancy or anything like that. I'll include a public static void main. It's not necessarily real descriptive, but it gives us a place to start. Okay, so we see that we have a functional environment to work in. So that's always a good first place to start. Now, if you don't have this, I'm going to question whether or not you had a good CS1 experience. And even the students that worked with me, you might have done something wonky, like you try to do it on Rappel or something all semester long. Hopefully you can remember how to get back to this. All right, so this doesn't actually help me much. So I'm going to come up here and I'm going to paste that in. Okay, so let's break this up a little bit. And actually, let's do one of these. And okay. Oh. Okay, develop a collection of 4 different rules for generating the terms of a sequence. Okay, so I think that's one of the first things that we're going to need to do. It says, so generate a program for randomly selecting a rule and a starting point. So for those of you that haven't worked on this yet, there's an entire section on sequences. And so we're going to go look at that. Give the user the first 4 terms of the sequence, ask them for the 5th. Okay, so I feel like we've got the opportunity to do some nice module coding here. Before we really get into that though, I feel like we need to have 4 different rules that we want to follow. And so for that, I'm going to go bop over. Let's see. Forget on this box where I've got things stored. I think I've got it here. And I might have bricked a few things, but we're going to give this a try. So under supporting documents, I usually have a copy of the discrete mathematics text. Now it's like an older version. Yeah, this one is bricked, and so Adobe Acrobat is no longer able to load this version. So I was working with a buddy, and what we ended up doing was just we uploaded a different version. It's basically the same thing, but when you see the file size that it's pulling down, that's because it's switching out the PDF. Okay. Yep. And that's why it's mentioned in there with the different file name. All right, so let's see if this is going to work now. All right. And there we go. That's what I was expecting to see. Okay, so we're in chapter 2, and we've got sequences and summations. And this, this is a lot of fun. I have a good time with this. Let's see. Where is the zoom button? There it is. This is the one that I want. Okay. So sequences. Consider a sequence. Yay. Okay. So here's a sequence. Did I say what this? So this is a geometric progression. Is a sequence of the form. Okay, so let's have a geometric progression. We might have the ability to do this. Let's do it this way. Yeah. All right. So geometric progression. So I'll just come in here and I'll say we'll do this. Rule 1. Progression. All right. Well, these things happen. So let's just take these 2 lines. We'll paste them in right here. A to the R. And I'm just going to all right. Okay, so hopefully we're able to come up with something like that, and we'll be able to work with it. Okay, now let's go back, and here it's example 2. And this is an arithmetic progression is a sequence of the form this. Okay, so I think this is a great example, and we'll just pop in here and we'll say Okay, so no exponents or anything fun like that. Do we get the commas and the periods and pluses? Yeah, this is all good. All right, one of the things is when you're copying and pasting out of a PDF, sometimes it'll just brick on you because it gets a squiggly line or something. Okay. All right, so this sequence, S of n equals -1/4 plus 4n. They are arithmetic progressions. Okay, so I think we'll just grab this and we'll see how that pastes in. And so rule 2, and I'm going to call it 2b. Okay, so technically speaking, those are two separate rules. Let's see if there are any more nuggets in here. Here's a recurrence relationship. Ooh. Okay. So this will be a recurrence. So this will be rule 3. Okay, so I'll come down here. Rule 3. Okay, and I'm not even going to worry about. Okay, I'm kidding. I can't stand to not pretty that up. A little bit. Okay, so arithmetic, geometric, and a recurrence. All right, let's see what else we have. Ooh, the Fibonacci, the famous Fibonacci. I don't know about you folks, but this is one that I like a lot. And there's a fun story that goes with it. And there's actually different ways to calculate the Fibonacci sequence, and there's fun ways that you can break a computer to calculate a Fibonacci sequence. But we're not going to worry about any of that right now. We'll just say rule 4. I think it's telling me fib o NAC, so it is two C's. Okay, so good times there, my friends. Yeah. And so the first term is usually given. This one actually has to have 2 initial terms. So won't that be fun? Okay, so we've got our 4 rules that we can go with. Fibonacci sequence, a recurrence sequence, a geometric sequence, and an arithmetic sequence. Let's see if there's any other fun type of. I think that's kind of a few ones that are popular. You've got lots of different examples to choose from. Now, summation is basically adding a bunch of other fun stuff together, and so it can give you summations, and they have lots of fun stuff that goes with them. There's what they call closed form solutions to summations, and so here's some of the discussion with that. But I think we've kind of ran our course on the sequences. So we're going to do those four: Fibonacci, geometric, um, arithmetic, and now I've already forgotten. I apologize. I'm doing this a little later than I normally try to work on these things. So, okay. So the first thing is we need to say so we'll say int rule selection equals get rule. I'll say get rule selection. And I'm not going to pass it anything, right? I'm just going to say I need something that returns an integer. So I'm going to say create this. Okay. So delete that, and I'm going to say return. I'm going to say int, and I'm going to do math.random, and then I'm going to have that. Okay, so if I multiply it by 4, it'll do from 0 to 4, not including 4. So I'll do it 0 to 4, and then I'll do plus 1. Oh. Well, that was weird. Oh. Somewhere, something it doesn't like. Okay, so anything that's got a squiggle, I'm going to, okay, so that doesn't seem to fix it. Aha, so it says maybe that's the one that it doesn't like. So I'm going to guess here. Yay, isn't this fun? So like I said, sometimes when you're having fun copying in things from PDFs, sometimes they get a little punchy. And they'll say, that's not a character I recognize. And I'm like, why did you use, okay, and that was it. Okay, so now we save it, we run it. Nothing real fancy there. I have no idea if this works, so oh. Rule selection, 3, 3, 4, 3, 2, 4, 4, 1. Okay, so I mean, it eventually gets all 4. All right, and now I'm going to say case rule selection. Okay, I'm tired. All right. Java switch case example. Obviously, I Google this a lot because, all right, so it's switch expression, curly brackets, case, break. Okay, so it is switch, end, curly bracket, and I'm going to do case 1. Is that the right syntax? Yeah. And we'll do no idea if that's the right spelling or not, and I'm not going to slow down long enough to worry about it. Home. I'm going to do 4, 3, 2. What's the third one called? Geometric, arithmetic, recurrence. That's what we needed. You know what? Why type? Why type? You can just copy and paste. Given the number of times that I've misspelled that already tonight, this is just easier. Fibonacci, geometric, Fibonacci, recurrence. Sweet. Okay, so now, we've got our rule selection set, and so let's just say, let's do this. This is a horrible way to program, by the way. It'd be make a lot more sense if I actually slowed down. And you know what? Let's just continue cruising along this horrible path. So before let's not do anything fun. Let's just do this. This is silly. It's fun for me. Okay. So I know, semicolon there. I'm going to say, okay, my brain can't get past this. Int user answer equals 0. Okay. Okay. Now I'm going to say user answer equals run sequence. All right, that's it. That's all I need to do. And now it's going to tell me, hey, that doesn't exist. So now I'm going to grab this line, create it, and see, there it is. Okay, now we can just do this. And I'll do that up just a line. Doesn't make a big difference. F11. Oh, it actually did work. That's exactly what we wanted to see. And see, this is how quickly you can fix errors. This is why I love programming. Okay. So now we can go in and we can have some fun, right? Because, I mean, why not? Let's make life interesting. I don't want it to be 0 because that might cause me problems later in life. So for sure, it's going to be between 1 and 100, something like that, right? I have no idea. Lucky that it got that one on the first try, but I'll take it. Okay. So A. So we've got A now, and now we need to say now I need to say int difference equals, and this time let's scale it back a little bit. Well, that's not as helpful. Okay, difference 4. All right. Okay, so let's do this. Okay. This is probably wasting more time than it's worth. But what I'm basically trying to do is I'm trying to make a way that this is going to kind of automate this. And so now we'll say, and then term. Oh, yeah, you're probably going to want to have one of these. Something like that, I think should do it. Okay. Punch this a few times. Okay. Term should be yeah, it probably wants to see this a little more like this. Okay, punch it a couple more times. Okay, 51, 59. So 51 plus 50, that's 8, plus another 8. Yeah, so it's 8 every time. And so what we need to do is this. And just for cleanliness, we'll, all right. So now we've got something that we can return. And so, let's just call it next number. Yeah. And so now I'll say if, okay, we'll say user answer equals, int user answer equals input dot next int if user answer is the same thing as next number, and you can say you are correct, else. I would actually feel cleaner on that. And now we will do so scanner, and we'll call it input, equals new scanner in. Yep, something like that. And now go ahead and import that little puppy. Everybody's happy. And now we can come down here. We'll say input dot close. And that takes care of all my warnings. Keep trying. Okay, here we go. 57 plus 2 is 59. Another 2 is 61, 63. I'm going to say 65. Okay, so we need to come back in here, and we need to tie that up, and we need to say eventually it'll get off this, right? There we go. Okay, so plus 4, plus 4, plus 4. So.
What are you doing here?
All right, so I'm going to take a break right quick. That's the first one. So
I was getting cold.
I'm going to go ahead and take a break. I'll be right back. All right, sorry about that. Go ahead and share my screen again. So what we see is we've got the first one. We can get it correct. Now, just to make sure, we're going to run it and see if I can get one to come up. Oh, I missed it. Okay. All right. So for sure, it's not going to be 11. Whoops. Don't want you up there. I want you down here. 11. Better luck next time. Okay. So we've tested positive and negative, and both of those still work. So now what we can say is we can copy this. So I'm going to come in here and I'm going to do the same thing I did last time. And I'm going to do this, and I'm going to copy this here, and I'm going to do now that does not exist, so go ahead and create it for me. Thank you. Now take this little person down here and paste this in. All right, now let's find the rules for geometric. Okay, so here's our rules for geometric. Okay. Okay, so a geometric progression is a sequence from, all right, so this one's going to be slightly different. So we just need a value for r. And so instead of difference, I'm going to call it ratio. And yeah, I'm going to slow this down just a little bit. I'm going to make it 5. So it could be 1, 2, 3, 4, 5. All right. And so now this one's slightly different. This one's going to be math.pow, and then we'll do ratio, comma, index. Now, why is it not happy? Probably because I need one more of these. And now, probably need to just do this. There will be things that we have to fix, but all right. Maybe have too many of these. All right. So starting number should exist. Math.pow. So what is it? Add, oh, yes, please do. All right, let's see if we can get a geometric sequence to run. So save that and run it. Fibonacci, no. Geometric. So 71 is our starting number. And then, so the difference is 1. So 1 ratio to the power. So a difference of 1. So the starting number is 71 plus 1. So and then that's plus 2, and then that's plus 4. I'm going to guess plus 8. So 86 is my guess. Whew. I need to get some sleep pretty soon. All right. These are actually out of order, and that's just going to mess with my little noodle. So I need to fix that just to keep my sanity. I always try to remember what Uncle Bob taught me. Uncle Bob says it should read like a storybook. And so you should have things down below in the same order that they are up above. Make sure I didn't. Okay, you know what? This is kind of giving it away just a little bit. And you should be able to guess what it is. Okay, so that's a difference of 3, 3, 3. So the next term should be 98. Arithmetic. 3, 3, and not 3. Okay, so difference here is 7. That's plus another set. Okay, so that's still There we go. We might have to recast those as, yeah, that's what we're going to have to do. So, okay, so because that was the giveaway before. Oh, well, and rule 2 still tells us that it's a, all right, so we did fix that. Okay, 1, 2, 4. That's strange that it's still, I would like to know what my ratio is every time. No. Okay, so 12. So 12 plus 5 to the 0 should be 5 to the 0. No, it'd be 11. 5 to the 0 is 1. Okay, so that means my starting number was 11. 11 plus 1 is 12. 11 plus 5 is 16. 11 plus 25 is 36. 11 plus 125 is 136. Yep, this is good. Now it's 11 plus 525, so it's going to be 536. Better luck next time. So I was wrong. I should say, let's see. How about I just got to know. Better luck next time. Tried plus next number. Okay. All right, so 9 plus 1 is 10. 9 plus 4 is 13. 9 plus 16 is 25. 9 plus 64. So it's 1, 4, 16, 64. So 4 to the 4th. What is that? So it's going to be 4 4th, 256. 256 plus 9 is, it's going to be one of those nights. 265. So now let's punch in 265. Is that right? Yeah, you are correct. Okay. All right. So other than my math is not good, it seems to be functioning correctly. Now let's see. Since I'm just going to comment it anyway, Okay, now it should not exist. Run recurrence. It is now up here. I'm going to move it down to where it belongs, which is down here. Paste it in. And it's a little more, in my mind, like this one. So I'm going to just copy this one. So a sub n minus 1. So that's our starting number is going to be this one plus 3. So starting number and then our difference. So as far as people are concerned, you really can't. All right, so if our starting number, say our starting number is whatever random number, and then our difference. So the way that we're setting up the algorithm, it really doesn't make much sense to talk about how these are different. So I'm going to comment this out. And so a recurrence, although it is a different way of finding, we should probably take some time and actually program a proper recurrence function. So I'm not going to do that because I'll admit I'm getting tired. I'll just come in here, Java recursion example. Java actually, I'll use the Fibonacci. We'll do a Fibonacci as a recursive. Okay, so we're going to need this, and we're going to change this a little bit. All right, I'm going to come in here. Okay. Oh, commented the wrong line. All right, so it's like, hey, that doesn't exist. So I'm like, hey, go create it. And it's going to put it right at the top here. So I'm going to come in here, I'm going to paste this in. And then I know that this one just kind of works and gets me close. So I'm going to grab it. And I'm going to paste it over this. Now we take this, go, and come down here. We'll paste this in here. Okay, so first thing we want is we want our definition out. Doesn't really matter. Second thing I want to do, I'm not going to give it away. Now, the Fibonacci number gets a little silly a little quickly. So I want to start with any of the first 10 Fibonacci numbers. This time we're not going to really need a difference. And so we're going to change our index. So I'm going to do from 1 to 5. Change this to just index. And then for this one, it is going to be, this one is going to be, we'll just return fib. By the way, you need to make this an int. And fib of starting number plus index. That should work. And then I'll just grab this. Okay. A lot of ways this could go sideways. Oops. That's how you can tell I'm getting tired. I just kept mashing the buttons. Must be getting an update. Oh, not the one I needed. And this thing's getting sloppy. I might have to turn it off and turn it back on again. Kind of wonder if that means I'm stuck in a loop on something, maybe. No, that does not look loop stucky. Okay. Oh, I see. It was waiting for my input. There we go. Wow, that gets out of hand real quick. So Fibonacci sequence, let's go here. Okay, so we're looking at what comes after 377. Hopefully it's there. So 610, punch in 610. Why did that not work? You are correct. Okay. So it does work. All right. Well, that is how to do it. And so this is not great programming. Not a great tutorial on how to do it. I just kind of pushed my way through it without giving it a whole lot of thought. There's probably more debugging that should be done. But anyway, I'm tired, and this is one way to work the program. I'm not saying it's the best way to work the program, but it is one way to do it. And so let's just walk through the program one more time so we can see what's going on here. All right, so I used packages. You don't have to. I used a scanner. If you're going to be getting user input in Java, you're going to need that. If you're going to use another language, you understand what the rules are. Giant block comma to just kind of explain, help me get my head on straight so I can understand the problem. This is where we kick off the main part of the function. Now, if you want to do everything in the main part, that's great. If you want to do objects, that's great. Whatever you want to do, I'm not going to complain too much. Because I've screwed up more programs than some people have written. I always start with this. You don't have to. What I'm doing here is I'm saying, hey, just tell me which rule you want to use. I could have easily, like, listen, this was a one line of code. This is maybe overkill. I get that. All I'm doing is I'm just telling it, hey, return a number 1 through 4. And this is the way that I do it. There's modulo operators, lots of silly ways that you can do this, but basically, it's a lot like you're playing eeny, meeny, miny, mo. However you want to do that in code, that's up to you. That's all this is. Okay. So once we've got that, I used a switch statement. You could do if statements. You could say, if my rule is 1, then do this, else if rule is 2, do this, else if rule is 3, do this. I just like the switch statement because it's okay. Give me just a second. I'll have to come back. Okay, sorry about that. Go ahead and share my screen again. So again, once we do eeny, meeny, miny, mo, we know which one we're going to call and do. Now, this is all still the top part. If I were you, what I would do is I would refactor this into another method or script, whatever language you speak, function, method, script. Because this is just, to me, this is just kind of sloppy. And you could also pass all this into a method. And I feel like there's some things that could definitely be cleaned up here, but this isn't a programming class. It's a discrete structures class. So I feel good about the arithmetic sequence. You know, we've got our A, which we're calling our starting number, and we've got our D, which is our difference. And we can see that we just kind of pop, 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 just like what they describe up here. The geometric sequence, again, is a pretty good match. Now, the recursive, honestly, there's a way to define a recursive function, but it's going to give a similar sequence to the arithmetic. And I got lazy, and so I didn't do the definition the proper way, but it gives the same end result. Now, the Fibonacci, we actually did use a recursive. And so let's talk just briefly about what a recursive means. So like here, let's say that our starting number is 7. So we come in here and we say, hey, what's the Fibonacci number for 7 plus 3? Let's 10, right? So what it'll do, it'll come down here and say, okay, so Fibonacci of 10. All right, if n equals 0 or n equals 1, which it doesn't, it returns n. Else, it returns the Fibonacci of 9 plus 8. So Fibonacci of 9, if it's that, it'll do this. Otherwise, 8 is going to be 7 plus 6. 7 is going to be 6 plus 5. 5 is going to be 6 plus 4. And you can see how it's starting to be recursive now. So if it's 0, then it's going to return in. And then if it's 1, it'll return in. So that'll be what's 0. If it's 0, it'll return 0. If it's 1, it'll return 1. So that'll be 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 2 is 5. 5 plus 3 is 8. 8 plus 5 is 13, and you see how it's generating the Fibonacci sequence now. So if you hadn't played with the Fibonacci sequence before, it's a lot of fun. Hopefully we'll get a chance to have a discussion about mutant bunny rabbits. I know in Computer Science 1, we usually talk about mutant bunny rabbits in a utopian island with, zombie mutant bunny rabbits. Yep. So anyway, that's the Fibonacci. That's what a recursive function looks like. And you can see it's got the recursive step, and then it's got the stopping criteria. And as far as a way of programming functions, it's extremely elegant. So anyway, this is one way to program the exam. This is the programming part. Now, what I want to point out, if you come here back to the exam, that's only part of it, right? So 50 points is to get a program that runs. Now, showing enough outputs to display your program is running correctly. If you're like, hey, see, it runs, and here's one output example, I'm like, that's one output example. I expect at least 8. Elaborate on that. Yeah, you put in a Fibonacci sequence. Cool. Did you show me that your Fibonacci sequence that you can actually guess the next number? Okay, so that's one. Did you show me that that it can tell you what's when you're wrong? So that's the second one. And then arithmetic, right, wrong, geometric, right, wrong, recursive, right, wrong. So the concept is, if you've got 4 options, you need to show if they're correct or not. So that's 8 outputs that you need to show. Now, the last part is the 5 parts. So a sentence to describe this, I would say, you're going to write a program that is make a quiz on sequences. All right, references and resources. You know, the book on summations and sequences was great. They had several examples and you can give the examples, you can give the definitions that you quoted. I think that's a good start. Now, a brief description of the assumptions to solve the problem and observations from the references. Okay, what I would say is we can assume that we are going to use integer arithmetic. We're going to assume that any general programming language should work. We're going to also assume that we don't have to worry about integer rollover or other weird artifacts that happen when we're programming things. Well, I would also say that just because you have the definition and some examples, you still got to write the code. All right, so your work showing your path from your question to your solution. I feel like this is a good spot where you should be able to kind of grab some of those Google search snapshots and be like, yeah, here's the first 100 terms of the Fibonacci sequence, and here's you know, one to the 0, or I forget, for the geometric sequence where you're adding things to powers. I kind of kept it small, but you might want to have something where you show what the tables are to kind of help you know what you're supposed to be getting at. And then a justification. You know, this is one of those things. You're going to play with it, and if it helps you learn the sequences and you feel like you know the sequences better now, you probably want to call that out and be like, hey, now because I've actually had a chance to program some of the stuff, I get it. Or if you're like, okay, I watched the video, I basically copy pasted Everett stuff, and I still have no idea what I'm doing. But it matches what Everett got, so it must be right. Hopefully you see the humor in that. Come on, you're going to trust a guy in a pink bedroom making a video on a Saturday night when it's okay. I'm an old man, so for to being up at 11:30, I'm laughing at you like I wouldn't trust anything that I did at 11:30 on a Saturday night anymore, unless I said I'm going to drink some Metamucil and go to bed. So, all right, listen, I'm going to go ahead and I'm going to sign off. Hopefully that's enough to get you started. Hopefully that's enough to get you going on the exam. Like I said, it's open book, open note, open neighbor, open Discord. Have some fun with this. Goof around a little bit. Um, there's Millie. I don't know if you guys remember Millie from Team Umizoomi, but she's always talking about pattern power. If you can get one to actually play Millie's pattern power from Team Umizoomi, I think that would be awesome. Um, if you could have like something from Dormouse, I think that would be awesome. Like if you want to get creative with this, I know there are some students that have also rickrolled me. I gave that guy stupid bonus points. Um, anyway, the concept is I hope you have a little bit of fun with this. I'm exhausted, so I'm not going to do that, but don't let that slow you down. Hopefully, you've got enough to get you started. Uh, enjoy, and I look forward to seeing what everybody has. Thank you all for your time. Have a great day.